Okay. Uh, Good afternoon to all of you. Just to start from where we had stopped in the previous class. First, we want to insert insert a node in a hash table. So we come to the else block when we do not find the key at that particular point. So the first thing we do is the find call the find function, and this is what the find function is. Now, initially, when initialization has happened, suppose we are sending a node as a key, right? We are sending a node which has got 100 as a key. So find list. In the find list, what happens is this is the node we like to insert. The base address of that is a 100. So what we do, uh, yeah, that example we have already considered. So we are considering to insert a node. We are considering to insert a node which has got the key as 10. Yes, Manish. Are you guys able to hear me? Is the voice audible? Right. The key, the new key, the new node which you want to insert is 10. So it comes over here. So this is an isolated node. So it's an isolated node. So the first thing is we are calling the find list find function, which has got two parameters. One is the list and other is the key. The list already has got one node which 100 as the key, having the base address as 1000. So therefore head is 1000 and tail is 1000. Head is 1000 and tail is 1000. So when the find function is called, it's supposed to return one integer value, right? So the list, right? What is that list? This is nothing but your single isolated single node list, which has got the base address as 1000. So when we enter this, when we call this function, ret value, that is a short form of return value, as 0, struct node temp. So this temp pointer is equal to list, which we have passed. That this is our list. So this list is equal to temp. So temp also becomes 1000, right? The pointer temp becomes 1000. Now we are entering the while loop. Temp not equal to null. Temp being 1000, 1000 not equal to null, true. So we enter the while loop. If temp of key equal to key. What is temp of key? Temp of key is 100, but the key which we have passed is 10, right? So this is false. This is false. So temp is equal to temp of next, right? So temp is equal to temp of next means what? Presently temp is at 100 and we go to temp of next. So that is null. And ret value becomes 1. Initially it was 0, now it becomes 1. Okay, so we come to the top of the while loop. Now the temp value is null, null not equal to null, false, right? So we return -1. We return -1, right? Though we have made the ret value as +1, it is insignificant one because we have come out of the loop and ret -1. So find index is equal to -1. Find index is equal to -1. It is matching. So the if condition is matching. That key 10 which we are trying to pass was not found in the existing list, right? The key not found in the existing list. Existing list was only having 100. And existing list was only having 100. So when we enter the if condition, array index of tail. Now presently the array index is 0. Its tail is 1000. So it comes to 1000. Thousands next. What is 1000 next? Presently null is equal to item. What is the item? Assume that the base address of this item, this null value gets replaced with 2000. This null value gets replaced with 2000. Then we come to the next step, array index dot tail. That is this array index dot tail. This is the representation of the array index. Index is 0 and its tail is presently 1000 is equal to item. What is item? 2000. So even this value gets replaced with 2000. That's how we have added two nodes at index 0, right? What are we considering? We are considering separate chaining. So or open hashing. So in this open hashing, linked lists are placed at a index array. And how do we reach that index array? We reach index array by a hash function. And what does hash function division factor? The hash function division factor is the maximum number of elements which we can store in the array, right? So this is what we had, I think, covered in the last class. So we'll go further. Now the further thing is what we'll see is updation. Now what is updation? Assume that this is the state. Assume that this is the state. we are still in the insert function, and this is the state. There is a head node at 1000 and the second node which is at 2000. Okay. Now the user is actually calling the insert function. The user is calling the insert function, but it is quite possible. It's quite possible that the user gives the key. The user gives the key which indexes at 0, and also it is already present in the existing linked list. It's already present in the indexing existing linked list. You cannot rule out that possibility. So that possibility we are considering. In the previous classes, we have considered when there were no nodes and insert the first node. Then we are also considered that the user is sending a node which is not in the existing linked list. Now, third case we are going to consider, wherein the user has opted for insert function, but he or she has given the key which is already existing. Okay. Now there are two possibilities. By mistake, suppose he has given 100 as the key, right? One possibility is that by mistake he has given, so he does not want to change the value and say, I do not want to change the existing value. Keys you cannot change. What you can change is values, right? So if he has got the option, if he says, no, I don't want to change the value, I want it to continue to remain same. So we simply come to this function and get out. Other possibility is that suppose he has given the key as 10, and when you prompt him that do you want to change this existing value, right? So he knows that yes, at key 10 by mistake he has entered some value which he wants to modify, right? So that case we are going to consider. Now when we already considered this, and this case therefore I put it in blue. Therefore I put it in blue. This was the case when the key is not found, that we already considered. So now let's consider the case in which the key is already existing, right? That is key found. Now when you are calling the find function, you have passed the list, right? To the find function you have passed the list. So the list is base address is 1000 and key, assume that 10, which is already there, right? So it enters the find function, ret value is 0, temp is equal to list. So this temp is equal to this first node base address, right? Now temp of key equal to key. What is key? Anyone? Are you listening, guys? What is this key which you are sending? $10. Yes. Good. Nikhil and others 10. So good. You guys are listening. If you are listening, then there is no confusion. We are sending 10. Temp of key is how much? Temp of key presently is 100. 100 equal to 10. False. So it's not getting into the if function. It's not getting into the if block. Temp is equal to temp of next. Temp is equal to temp of next. So temp of next becomes 2000. Right? Sorry. Temp of next becomes 2000. So 2000 not equal to null. Temp of key is how much now? Is it 100 or 10? Rohan, it is 10 because we started with first time when you enter the loop, temp is equal to 1000, right? When you enter the while loop, temp value was 1000, not equal to null, true. Temp of key is 100. The key pass is 10. The key passed is 10. Temp of key is 100 equal to 10, false. Therefore, we did not enter here. Temp is equal to temp of next. What is temp of next? 2000. So we have come here, 2000. Okay. We have come to the top of the, this becomes 1. We come to the top of the while loop. Still not null. Still not null. Right? Not null means what? We enter the while loop again. Now, since we are here, the temp of key is 10. 10 equal to 10. True. Yeah. Right. So And second thing, so when temp equal to temp, red value, right? What are we going to send red value as? Return value as? One. Very good. Return value as 1. Good. So this is what happens at the find function. This is what happens at the find function. So obviously this is not equal to 1. I mean index is not minus. So we come to the else. We come to the else part. So here I just commented that the key already present in the linked list, updating the value of already existing key, or by mistake if it is there, you may say no, right? So let's consider, I'm just displaying that do you want to change the value, right? Means what? I have already identified that the key, this key 10 which was given by the user, the key 10 which was given by the user is already there. So I'm assuming that the user may like to change the value. Therefore, I'm putting a question, and we are saying that select one for updation. If it doesn't select one, then it is he doesn't want to update, and by mistake he has given the same key, right? So I'm scanning it, and let's say he has given one. One means what? He wants to modify this 10 value. The value at key 10. The value at key 10 presently is 1112. He wants to update. So let's say he has entered 1 as per our request. So I equal to 1. This I equal to 1. Now there is one more function which gets called struct node element. Struct node element, right? That struct node element, get element, list and find index. List and find index. What was this find index? What was the find index, Sanjana? Yeah, 1. I hope you will remember that. I hope you will remember that. That's 1. Okay. So this get function method gets called. That's what is this get element method, which has got first parameter as struct node list and second is find index, right? So the first part, that is this list part, is 1000, right? These are the base address, and find index is 1, right? As Jolly has correctly said, and you most of you has already said that this find index is 1 and this is at 1000. So there is a local variable I. Local variable I is equal to 0. Now we are creating one more temp. We are creating one more temp and assigning the list value, right? So this temp 1000, presently I value, this local value, which is equal to 0. At this point I am talking. At this particular point, the temp value is 1000 and the I value is 0, right? I not equal to find. What is find index? 1. What is I? 0. 0 not equal to 1. True. 0 not equal to 1. True. So we enter the while loop. When we enter the while loop, temp is equal to temp of next, right? So temp is equal to, presently temp is here, temp of next is 2000. So we have brought the temp here. We have brought the temp here, and I value has become 1, right? So this local I value has become 1 and the find is also 1. So 1 not equal to 1, false. Return temp. Why are we returning temp? Oh, Sanjana, any? Okay, some students are having some issues. Yeah, please go ahead. why are we interested in sending this is my question. But before that, students were typing. I did not notice. Any questions? Sanjana, Rohan, you are using the chat window? No. Okay, then can you answer my question? Why are we interested in coming to this and return that? What is temp? Temp is standing here. Temp is standing here. Why are we interested in return temp? What is the return type? Struct node. So that temp. So Nikhil Reddy is saying we need to update at that node. Very good. So that we can change the value. Aman says correct. Particular node we want update. Rohan, you are right. Bhavana, so that we can change the value. Correct, Bhavana. And Teja also says because we are interested to change the its value. Yes. So Meghna also you are right. And return 2000 so we can get the element and can update. Right. Yes. So good that you understood. So now that the return type we are at this call, the call has returned temp. So element the value in here is 2000. The value here is 2000. Now, if the value is 2000, what is happening next? Let's see. Now, this element is nothing but 2000. Element of value is equal to value. That value, we are already key value while inserting, we are saying key value, no? So that key value, suppose assume that it is 2222. So that value gets modified with this value. This value gets modified with that value and it gets updated. It gets updated. And we close and suppose there are two options. We are asking the user, do you want to update? Now the user may give 1 or he may give something which is not 1. Something which is not 1. So in the second case, suppose he gives not 1. Then we come to the else block and we print no change in the value. We print no change in the value. So both the cases we have considered. We have, or rather 3 cases we have considered. First, we started with 0 nodes. We added the first node. Then we added the second node. These are the first 2 cases. The third case is he has given the key which is already existing and he wants to change the update the value. So that case we have considered. And fourth case is that he has given the key which is already existing, but he doesn't want to change, right? So that is how the entire insert function is complete. The entire insert function is complete. But before that, I have already sent a PDF of skip list. I have given it to Shankar sir to share with you. Have you received? Has it been shared? Yes, sir. Okay, good. Okay. Similarly, once I finish this, I'll send the PDF for that. But do not, the PDF is not the .c. So you have to copy paste and in the this thing editor and give the extension as .c. Then only it will execute. Otherwise, it is not a .c file. It's not it's a txt file. Bhavana. Okay. Bhavana, the change value is here. One minute. I think I've gone very far. One minute. Just hold the line. here, when you are calling the insert function, the key and value, this value, right? So yeah, see, this insert function started here, no? So we first considered all that. First initialize the entire array with null and all that. Then we added this 100 key, isn't it? Then we added 10, and after adding 10, we are updating, right? So there are two possibilities. Either we update or we do not update. So both the possibilities we have considered. Okay. So with that, we are done with the uh, insert function. Insert also incidentally updates in case the key is existing. If the key is not existing, it's going to insert the linked list in our hash table. Okay. Now let's come to the last part of the hash table code as such. The see actually it is written insert, search and delete. Have we done search, students? Have we done search? No. Are you sure, Nikhil? Have we done search? Yes or no? Durga Prasad, when did we do search? Yes, find index. Isn't it, Ron? Sorry, Suryateja. Find is nothing but search, isn't it? Existing key. So that's a search. Okay. So explicitly, I'm not going to talk about search because that find function is already there in the search. So the third one left is delete. Right. The name of the function is remove underscore element. So whichever node you would like to delete, that key you are required to pass. So the existing one, let's consider. We have two nodes at index 0. One is the head is at 1000 and the tail is at 2000. So when we call this function, it is going to ask hash code. It's going to ask hash code. Suppose I would like to delete the first node. I'd like to delete the first node. Now here also there are two cases. One case, the first node in the linked list to be deleted, the last node in the linked list to be deleted. And the third case is that by mistake you are given a key which is not there in the linked list. So we should say that the key does not exist. So these are the three cases. Yes, Nikhil, ready? But find takes list as parameter. Yeah, so you can find only when the list is there, no, Nikhil? If the list exists, find exists. If the list doesn't exist, find doesn't exist, no? How do we search for one key? Yeah, that's what the find does, no? Particular key, that's what the find. You are sending the parameter also in the find. In the find, you are sending the key also, no? Yeah. So now I'm sending a key. The key is say 100. Okay. So the first thing is called is the hash. What is 10 hash function? You know 100 by percent has 100 percentile 10. That results into 0. So this index is 0. So we are coming over here. So index is 0. Okay. Now the list struct node, right? Now this list not equal to null. Sorry, first thing, list equal to null, because list value is already 1000. List value index of head. What index we got? 0. So array 0 of head. What is array 0 of head? 1000. Right? So this pointer gets the value called as 1000. Right? So the first if condition that equal to null is false, because it's not null. Right? So let me finish. Suppose there you have sent 200. Key you have sent 200. Hash code 200 percentile 10 0. 200 percentile 10. Okay. If not here, then instead of sending 200, suppose I have said 110. 110 has resulted into what? Say 111 say has resulted into 1. Hello? Hello? अच्छा ठीक. Last 2 days is नया होता. हाँ. चेक नंबर बोल रहे या कार्तिक? एक मिनट, मैं क्लास ले रहा हूँ, होल्ड करना. Is Karthik in the class? AW Karthik, who has sent me a message. Hello? Karthik, who has sent me a message. Are you in the class? Karthik, are you in the class? Come to the chat window and respond. अच्छा ठीक है, मैं उसको क्लास में नहीं आना, मैं उसको बोलता हूँ करेक्ट नंबर दे. रोल नंबर ना, ठीक है, मैं बोलता हूँ. Suppose I send the key as say 1 percentile 10 is 1, right? And see if it is null, head of this is null. Assume that only this linked list is existing. So at index 1, 2, 3, 4 up to 9, all are nulls. This head is null, this is null. So index 1 of head will be null, right? So list is null, list equal to null. This key does not exist. Straight away we give that point. Am I clear? Because there was little disturbance. Suppose the key value sent here is 1. Assume that only this linked list exists. So 1 percentile 10 is 1. So you are coming to index 1. At index 1, the head is null and tail is null, right? So array of 1 of head is null. So list is null. List equal to null, true, and it enters here. Okay. So you are giving a prompt that the key does not exist. Now what we have done is we have sent 100 and 100 is there. So the base address which is there in list is 1000, right? So list equal to null is false, so we come to the else. We come to the else part. Now I'm saying find index. Find index. So we have passed list as 1000 and key as 100. Right? So the list is 1000 and key is 100. List is 1000 and key is 100. So we do not go here, that is this key does not exist part will not be there. So we come to the else block, right? Because the key is already there, -1 won't be returned. So ret value will be something non-1, non-1. In this case 0. So since it is 0, find index, it comes to the else part. Now temp is equal to list, right? So this temp is equal to 1000. Are you following me? Temp is equal to 1000 because the list is at 1000. Now if temp of key, how much? Temp of key, I already given it here, 100. And the past key, the given key by the user is also 100, right? This is equal to this. Okay, this key equal to this. So this is true. This is true. If this is true, what we are doing? Array of index is 0 of head is equal to temp of next. What is temp of next? 2000, right? 2000. So head becomes, this becomes 2000, right? So this key has been removed and returned. Are you following this? Because now existing are two nodes. Existing are two nodes. Now out of which this node gets deleted. So the linked list has got only single node at index 0. Since it is a single node index 0, both will be 2000. Both will be 2000. Are you following this? Are you following this, students? Both will be 2000 because head will be at 2000, tail also will be at 2000. Yeah, you can shoot the question. Multiple students are trying to access the chat window. I'm sure there are doubts. Somebody submit so that I will come to know one by one. Actually, due to connection issue, acha. Venkat Karthik, you sent me a message regarding your fees, right? Are you same? Respond it in yes, no. I'm waiting. The class is standard. Did you send me a message regarding your fees? Yes, about payment issue. So you please send me your correct roll number. Last time when you sent the roll number, the two digits were missing. You WhatsApp me your roll number. Okay. Okay. Now coming to the deletion of this particular node. Coming back to the deletion of this particular node, this value gets replaced with 2000 because this is the only node which is there. This we have already removed. This we have already removed. So this becomes 2000 as per index of 0 of head is equal to temp of next. What is temp of next? Temp was here. Temp of next is 2000. So this gets replaced with 2000. And when this gets replaced with 2000, this node goes. So we got only one isolated node, not isolated, only single node at index 0. Any clarification regarding deletion of the first node in the linked list? In case you have any doubt, please come to the chat window. This is how we delete the first node in the linked list. Looks like all of you are following. Now let's see the other case. Let's see the other case. Now this is the existing linked list. At index 0, we have one node at the head node with key as 100. The second node in the linked list is the key of 10, and the base address is 2000. Right? Now the user has passed 10. He wants to delete this, the last node. The user wants to delete the last node. Right? So this is an example of last node also. Right? This is an example of last node also. Now the user has sent this. So temp is equal to 1000, key is equal to 10, find next is equal to 0. Right? Now, so this won't happen. We come to the while loop. Why it won't happen? Temp of key is how much? Temp of key is 1000. Temp of key is 100. 100 equal to 10. No. So we come to the while. We come to the while. In the while, temp is equal to temp of next of key. Are you following this? Temp of next of key. Temp is where? 1000. Temp of next is what? 2000. 2000's key is what? 10. So 10 not equal to 10. True or false? Are you following? But this logic, are you following? Meghanandi say all of you are right. But are you following this concept? Temp of next of key. Temp of next of key. Okay. See, presently the temp is at 1000. That is here. Temp of next. Next is what? 2000. So I come here. 2000's key is 10. So temp of next of key, this is 10. This is all is 10. And the value passed in the key is 10. So this is false. And this is the only statement in the while loop. So it won't do this. It won't do this. So it comes over here. It comes to the temp of next of key is equal to 10. Right? So array index of dot tell. Array index. What is index? 0. What is the tail? 2000. 2000 is equal to temp of next. Is it true? Yes. What is temp of next? 2000. What is array index of tail? 2000. So 2000 is equal to 2000. True. So temp of next is equal to null. Students, are you following this? See, let me start here. Temp, we actually, the key pass to be deleted is this 10. Right? When the list is having 1000 as the base address. Unfortunately, it got deleted. So this base address is 1000. So temp is equal to list, that is 1000. Key pass is 10. Find next is 0. So temp of keys 100. 100 equal to 10, false. So we won't go here. We come to the while loop. In the while loop, temp of next of key, temp which is 1000 of next which is 2000 of key is 10. This is 10. Key pass is 10. So 10 equal to 10, true. 10, but the condition is not true. not equal. Okay, so the condition fails. So I don't do this. I don't do this. So I come to the if condition. In the if condition, array of index, this index which has written is 0. So this is 0. Of tail is 200, correction, 2000 is equal to temp of next. 2000 is equal to this. Temp of next is also 2000. Tail is also 2000. This is true. So temp of next is equal to null. So this becomes null. Why should we make this null? Yeah. To delete what? Bhavana. To delete what? Correct. Correct. So since this is the node which is connected with this and the request has come to delete this particular node. So when this node goes, presently this is the last node. What is the indication of last node? The next should be null. Presently this is not null. So this has to become null. Then only from the two nodes linked list, we reduce it to one node linked list by deleting the last node. Okay. So temp of next equal to null. So this becomes null, right? And array index of tail is equal to temp. Array index of tail is equal to temp. What is temp? 1000. So that's become 1000, right? Because it has entered the if condition, it won't go to the else condition. It won't go to the else condition and move out. To delete the next. Yeah. So students, and of course, after that, this node gets deleted. So that's how the linked list has got reduced by deleting the last node in the linked list. The linked list has got reduced by deleting the last node in the linked list. Any clarifications? Anywhere you are not understood? Those who are not understood, please come to the chat window. Okay, so looks like all of you have understood deleting the first node and deleting the last node. Deleting the first node and deleting the last node. Now there could be one more possibility, in between node, right? In between node. So 100 is at the head, 50 is the in between node having 1500 as the base address. So this next is 1500. Bogaram, yeah, with this example I'll explain, Bogaram. Is it okay? You will understand the while loop much better. Okay. And the last node is at 10. All are indexing to 0. So in the existing linked list, we have three nodes. First is 100, second is 50, and third is 10. 100 base address is 1000, 50 base address is 1500, and 10 base address is 2000, right? So this continues to be 2000 because this is 1000 is the head of the linked list and 2000 is the tail of the linked list. Okay, so the user wants to delete the in between node, right? The user wants to delete in between node means what? We need to do the presently 100 nodes next should go to get replaced with 2000, right? So that we have to manage with the while loop. Okay, so the user has sent a request for 50 as the key, that is that node to be deleted, right? So Here it is false because 10 and the user request is 50. So it won't enter the if condition here. So it comes to the while loop. Now what is this? While temp of next of key. Temp is here, of next is here, of key is this. Not equal to 50. Right? Is it matching or not matching? Bokaram. While loop. Is it presently matching or not matching? Is the while condition getting satisfied or not satisfied? Once again, when we were here, this is false because temp of key is 100 and asked is 50. So we come to the while loop. While loop says temp of next of key. Temp next of key 50. Right? Not equal to 50. Not equal to 50. Is it true or false? False, isn't it? Means the condition is actually matching, but the condition is not matching. So false, right? So it won't enter the while loop. It won't enter the while loop. So probably Bogaram wants to see a case wherein at least once it enters the while loop. Once it enters the while loop. So if we have the next key as say 40 Bogaram, probably it will enter the while condition and it will go to the next. That's how this while loop will work. Bogaram, assume that there are 4 nodes. This is 100, this is 50, and we have one more 40. We have one more 40. So here temp of next of key is 50. 50 not equal to 40. True. Temp is equal to temp of next. It will come to 50. Right? When it comes to 50, temp of next of key. 50 is next of key is 40. 40 not equal to 40. False. And we come out. Bogaram. Right. So presently, the second node. So this condition being false, array index is 0 of tail. Array index of tail. What is the array index of tail? 2000. Right? Temp of next is how much? Temp of next is how much? Students. Array, I'm in the if condition. Array index of tail is 2000. What is temp of next? Right? So this becomes, it comes to the else condition. In the else condition, what is there? Temp of next. Are you following this? Presently temp is at 1000, right? The while loop failed. So it comes to the if condition. In the if condition, the tail is 2000 and temp of next is 1500, as Bhavana is saying and Rohan is also saying, right? So the if condition has failed. So it comes to the else. Else is what? Temp of next. What is temp of next? Is equal to temp of next of next. What is temp of next of next? Temp of next of next. So this 1500 gets replaced with 2000. Because it gets replaced with 2000, this node gets deleted. This node gets deleted. And our linked list looks the way it is. Looks the way it is. Are you okay? Anybody is not understanding the delete? the in-between node. The in-between node also can get deleted like this. Anybody who has not understood, please clarify. Else part once again. Yeah, sure. See, the requested key is 50. So this node is targeted to be deleted. So temp is equal to list. So temp is your 1000. Requested key is 50. Temp of key is 100 equal to 50. False. It comes here. Temp of next of key 50. 50 not equal to 50. False. So while condition fails. If condition. If index 0 of tail, how much? 2000. Temp of next, how much? 1500. False. So it comes to the else block. In the else block, where is the temp? Temp is here. What is temp of next? Presently 1500. To be replaced with temp of next of next. Temp of next is 1500. Of next is 2000. Right? So this particular 1500 gets replaced with this 2000. Right? So when it comes to the else block, this gets replaced with 2000. When this is getting replaced with 2000, this node is no more connected to this node, but directly connected to this node. So the in-between node gets deleted. Sahitya. Okay, good. So this is what is your delete function. This is what is your delete function. Now I'll briefly give one introduction to your presently we are considered your separate chaining. So in the separate chaining, that is open hashing or separate chaining, now the doubt will come, or probably someone may be saying why there is a confusion, like open hashing also is said and separate chaining is also it is said. So it's separate chaining because the key value pair is in the form of a linked list, right? And at every index we are attaching one linked list, right? We are attaching one linked list. So actually the key value pair is not in the table, right? We are going to what is the table here? The array. So by that hash function, we are going to that array index, and at that array index, dynamically we are either inserting a new node, or we are dynamically removing a new node, right? So at every index there being a different linked list, therefore the name separate chaining. At every index in the array there is a separate linked list, therefore the name separate chaining, right? And since it is open for adding the nodes, so it comes under your open hashing. In open hashing, key are mapped to array index and values are stored in linked list attached to the index of the hash table, right? Our basic hash table is our array, right? Wherein we are storing the head and the tail, right? At that index we are storing the head and tail. Head and tail of what? Head and tail of the linked list which is there at that particular index. So in open hashing or separate chaining, the keys are mapped to array index and the values are stored in a linked list, right? Now on the contrary, the second one, that is the closed hashing or open addressing. Closed hashing. In this closed hashing, all keys are hashed to an array index and are stored in the hash table itself without the use of linked list, right? So in the second close hashing, we are not going to create a linked list. We are not going to create a linked list, but we are storing at that particular index the value. We are storing at that particular index the value. Okay. Now there are several kind of a open hashing algorithms, right? There are several well-known probe sequences. Probe sequences means what? Probe means at which index, at which index I should be storing the value is our problem. Okay, so the three which are there in your syllabus is, one is linear probing, which I'll cover the algorithm part. I'll cover in today's class. Then there is a quadratic probing. Then there is a double hashing, right? So let us go linear probing, the algorithm part. Okay. Now let's see one by one. Assume that the division factor of your hash code function, the division part of your hash code function is 13. 13 means what? There are 13. The size of the array is 13. The size of the array is 13. So first value given is say 18. So when we say 18 percentile 13, 18 percentile 13. So this is my array from 0 to 12. The size is 13. Therefore, the division factor is 13. Right? So what I do, I take this as the key, pass it to the hash code, and come to the index and store this as the value. So at that particular index itself, we are storing the value. Right? At index 5, straight away we are storing the value. Unlike the previous case, we are not creating a linked list over here. We are not creating a linked list over here. Now the second part, that is 41 is the next value. This value acts like a key for the hash code, right? So 41 percentile 13 is equal to 2. So what we do, at the index 2, we are saving 41. At index 2, we are saving 41. Now, actually, the one thing which is in red is to be concentrated and to be understood clearly. So, as far as 18 and 41 is concerned, I hope there is no doubt. 18 percentile 13 resulted into 5. So, we saved it at this. 41 percentile 13 resulted into 2 as index. So, at index 2, we have saved 41. Now, the third value is 44. Now, 44 percentile 13 is 5. How? 13, 3 the 39. 39 plus 5 is 44. So, remainder is 5. Okay. But 5, we already have 18. Right? At index 5, we already have 18. So, what has happened? Collision. What has happened? Collision. Now, when the collision happens, see the algorithm here. When the collision happens, what they do is increment the index which has come by 1. That's what I'm showing here. Actually, the remainder is 5, but at 5 we have 18, right? At 5 we have 18. So what we do, this 5 index we increment by 1 always, a constant factor. So we reach at 6. At 6 presently there is nothing, so we store 44 at 6. Students, are you getting my point? When the collision occurs, do not think about 59, 32. I am going to take each example and to explain to you. But presently 44 is clear. Increment it by 1 and see if it is vacant. Vacant means what? There is nothing. So 44 is saved. Now the next key, right, is 59. Y to increment. See, Y to increment, Raghavana, is like this. See, at first 18 we wanted to save. 18 occupied the place of 5, index 5, right? Then 44 came. We can't say 44, sorry, there's no place to get out, right? So we need to accommodate. How do we accommodate? So whatever this hash code has written, the hash code has written 5. If there is a collision, then we have to write a logic to increment it by 1. What? The index. So the index 5 gets incremented to index 6. Index 6 is empty. Can't we decrement? Yeah, see, the linear probing method, it increments by 1. Linear probing method increments by 1. Now coming to your question, Raghavendra, there are certain algorithms wherein you provide a seed also. Seed means what? What you are saying, why not -1? So that seed which you are providing, it could be -1, it could be 2, it could be 5. Now in case it is -1, it decrements to 4 and you save here. In case the seed is 2, the collision has occurred at 5, so it doesn't store at 6, but it stores at 7. If the increment is 4, though this is vacant, this is vacant, this is vacant, it will save at 9. Yeah, nickel ready is also correct, but there are other ways nickel ready. Then it will route back to the tail of the array. So first let me close Raghavendra's case. Raghavendra, the seed factor generally it is a positive number, not a negative number. So that positive number goes toward the end of the array. Raghavendra, are you clear? Right. So we were now at 59. Now 59 percentile 7, right? So the remainder is 7, isn't it? 13 for the 52, 52 plus 7 is 59. So 7 index. So presently 18, 41, 44 is occupied. So it has come to 7, which was as such empty. So no issues. We added here. Next we come to 32. 32 percentile 13 has resulted into 6. But at 6 already 44 is there. Right? So what we do? Step 1. Increment this 6 by 1, resulting into 7. Right? But at 7 there is 59. Right? Again increment this 7 by 1, make it 8, and presently 8 was empty. Therefore we place it at 8. Like that the other examples. Students, have you understood increment by +1? Have you understood increment by +1? Okay. So now search operation. Now the search operation, in the search operation, the key given is say 31. The key given is 31. Now 31 percentile 13 has resulted into 5. Yes or no? 13 to the 26 plus 5 is 31. Right? So at 31 he has come, but the key given is what? 31. We came here 18, not found, increment by 1, 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 not found, increment by 1. Increment by 1, and then it will return the value. Now the second case. We are looking for 19. We are looking for 19. So it kept on incrementing. Now coming to Nikhil Reddy and Raghav's discussion. We are looking for 19. It went on incrementing. Not found, not found, not found, not found. And after 73, there was a blank. Right? The moment there is a blank, straight away we return not found. It doesn't go to index 0 because we found a blank. Right? I have not answered that Nikhil's issue. So this is one case. The second case, we have the array filled like this and we are looking for 19. We are looking for 19. So in the first case, we have gone up to the end of the maximum size of the array. The maximum size of the array is 12. So we started from this and kept on going to 12. Since we reached the 12, we continued from index 0. Right? In the other case, Nikhil, if something Raghav is saying negative, so when you come to 0, we loop it back to the size and decrement it. Nikhil. Right. So since we reached the maximum size, but we have yet not found 19. And the starting point was not 0 index. Since the starting point was not 0 index, we looped it back to 0 index and we kept on coming up to 0.6 where we started. Right? Since it came back to index 6 and 19 was not found, so we return not found. We return not found. Okay, so this is the algorithm. This is the algorithm of your linear probing. This is the algorithm for your linear probing. So now I hand you over to Shankar sir. I hope there's a quiz for you. Yeah, Raghavendra, go ahead. You're ready for the quiz? When there is a doubt, so I clarify the doubt and I'll exit. Yeah, you are watching, no? You are watching, no? Okay, great. Just a minute. That means, sir, that the number of key it can hold is limited. Absolutely right. That is the limitation. Very well brought out, Durga Prakash. Very well brought out. So, what happens when the array is full, right? So we go for linear probing only when we are certain that the number of keys are limited. When the number of keys are limited, right? Therefore, that name, separate chaining, the chain is there. The chain in the linked list case, the chain can endlessly go on to infinity. So there is no limit only there. But in this case, there is a limit. So what happens when the limit is reached? What happens when the limit is reached? So in such algorithms, what they do, in case the array is full, increase the size of the array is one option. Which they give. Raghavendra is saying, sir, if we find a blank space and next to it element which we want to find, will the element be found? there would have been a blank space. I'll go back to your thing. Uh, this was the case, right? Yeah. You are go. It will directly goes. I don't know. That can't happen. I agree with Jolly. Suppose while inserting 19, if this is the case, Raghavendra, while inserting 19, 19 would have taken this slot. Uh, this is a search I'm talking about. While inserting, already these elements are there, and I ask to insert 19. 19 would have come and 19 would have occupied this place. Yes, no. But 19 is not there. Because 19 is not there, therefore this blank, therefore this blank. So there's no need of looping back to 0 and looking for 19 is there or not here. The fact that there's a blank, it means that it was not inserted. Aman, do you want to say the same thing? That can't happen. Yeah. Raghavendra, are you clear what I explained? If I have understood your doubt, this is the answer. Raghavendra, have I answered your question or the doubt is something different? Yes, sir. But can we sort and do the binary search to find the elements? See, the difference between the skip list and the hash table. Hash table does not believe in sorting. There's a different type of data structure. It doesn't waste time in sorting job. It just keeps on adding the elements as they come. Therefore, we have therefore we have taken the different data structure as such. In the skip list, the sorting of both the normal lane and the express lane has to happen. But here, no sorting part. Therefore, there is separate chaining appended respective. Yeah, I'll deal with it a little later because unless I do not explain what is complexity, right? The, here, because it's an array, here it is an array. The the search operation, what they say, it goes at big O1. Sir, you explained earlier. Acha. But I mean, somewhere in the middle I have explained, but once again, starting from what is this big O notation, from that point I would like to take it. Okay, so if there is no doubt, there is a quiz. So I'm logging out and see you on Wednesday. See you on Wednesday. Bye. आणि पावर पुण्यामध्ये लॉकडाऊन आहे. फक्त नसेल होता आता अनाऊन्स केलं की अफवा आहे लॉकडाऊन अनाऊन्स झालेलं.
नवीन ग्रुप सुरू केला आहे तुला आलंय का 28वी कॉन्डो बुलेटिन म्हणून Have you got it?
Yeah, good afternoon, everyone. Yeah, good afternoon, everybody. Is my audio is clear? Okay, Sudha, thank you. Yeah, in the earlier, I gave you questions on hashing, and I gave one program also, right? Like inserting, beginning, ending, at the end, and the middle, right? So the most of the student maximum has completed. So if I want to say that one, so 215, 215 students have got green stars. In the sense, they have executed one test, full complete test cases. He allocated as an 100 out of 100. So I'm very happy that one. A lot of that students from entire section have a good coder. And also, we conducted the quiz also, right? In the quiz, 289 students got full out of full. Means 10 out of 10. I gave you 10 questions, right? The 10 questions, full students got. Sorry, it's a 286 students, right? So 286 students got full out of full 10 out of 10. So I'm very happy that one because each and every students are following quiz. I can call as a concept whatever the miss is explaining you, right? These are the students. Right now it's 47, right? These are the many students got full out of full. Yeah, today also we have the same type of questions. Okay, just I'm going to start that quiz, and those are missing the questions. So those are getting 7, 8, 9 questions. I have a small explanation for that one. Okay, before that I will start the quiz. It is also a small 10 questions, which will cover linear hashing. Okay, guys.